Okay, the next one then is we're going to look at impacts on infrastructure. So changes in things like temperature or precipitation affect how societies operate. If there is a sudden change or rapid change, this is difficult or expensive to solve. It doesn't mean it can't be solved, but if you are spending money on flood defense, you're not spending it on hospitals or pensions or education or investing in new technology or something like that. So there's an opportunity cost associated with it. So let's have a look at some examples. Our first one then is road heat stress. And this is where the tar that makes roads, so in tarmac, deforms under the temperature, the high temperature. And this means that it needs to be relayed, which is expensive, and it might need to be relayed using higher melting point. Tar or tarmac, it's technically asphalt, so that it can cope with that. And the higher melting point means it takes more energy to melt, and that makes it more expensive to lay and all that sort of stuff. Next one then is track buckling. So track buckling is where railway lines sort of deform in high temperatures. So the track is tensioned before laying, and it's tensioned for a specific temperature, so something like 27 degrees centigrade. Any temperature below that causes contraction, which just places it under greater tension so it stays nice and straight. If temperatures are above 27 degrees centigrade, it expands, and this results in deforming rails, which is dangerous because you could have a derailment and lots of people getting hurt. And as a consequence, you might need to lay rails with a higher tensioning temperature. So more like 32 or 35 degrees centigrade, and all the cost that is associated with relaying rails that are already there. You have things like drainage. So if you have higher rainfall or intensity, so more rain in a set amount of time, this will result in a higher risk of floods. So you might need to put in hard flood defences. So this is things like flood walls and stuff like that, or flood channels, which is expensive. Or you might have to do soft flood defences, which is extensive, which means it takes up space. Things like rewilding a catchment, putting in forestry, reforestation or afforestation, meanders in the river, leaky dams, all these sort of things. They're not so expensive, but they take up space, and that needs to be paid for in a different way. One of the examples of how drainage has changed is things like SUDS, which is sustainable urban drainage. So that should be a little s. There we go. So sustainable urban drainage, which is where the area covered by impermeable surfaces in a development is sort of replaced by drainage and floodwater storage. So this is to prevent rainfall falling on a new development, flooding things downstream. And you see these in new housing estates where they have big like ponds and bunds around the housing estate, sort of at the bottom of the housing estate, to capture water that flows in off of the like roads and roofs and stuff like that. So the rain that falls on impermeable surfaces drains into the pond and is stored before being allowed to trickle out over a long period of time. So storage and delays discharge. Another one then, another impact on infrastructure is things like landslides. So you have heavy rain falling on an area, it becomes saturated, so it cannot take in any more, it becomes waterlogged. This means it's heavy and also lubricated by the water between the particles, and this makes landslides more likely. And we've seen this in the southwest with landslides in cuttings for railways and things like that. Deforestation has a big makes this more likely. Because the roots of the trees hold the soil together, and if they've been removed, then it's more likely to fall apart. And the last one we're going to use as an example is bridge damage. And bridges can be damaged by high river flows that carry debris, things like trees and stones. These can then damage bridge supports. So you have, this is especially prevalent in older bridges, which are a bit more limited in how you can make them. So it'd be an arched bridge. You will see these thick pillars between the arches to carry all the weight. They might have like this sort of island structure, like the bow of a ship, to allow some of the water to pass a bit more sort of efficiently, but it increases their contact with the water. There we go. So here's our river gurgling past. And if you get things like trees or logs being washed down, what can happen is they can become jammed. That can either directly damage the bridge itself, or it can build up more logs and branches and debris, which acts as a dam, building up the amount of water behind it, which can increase the amount of scouring of the pillars or cause flooding upstream, or result in failure with all the pressure of water on the bridge. Newer bridges, modern bridges, have much narrower and streamlined pillars, or you could avoid the pillars entirely by having like a suspension bridge or something like that. Okay, so we got a streamlined, narrow support. Okay,